Hi everyone, today we're going to speak about quantum mechanics and physics. For that we'll talk about what it studies, how it studies it, and we'll talk about some of the scientists who made this field advance. So first of all, as you might know, the classical physics in everyday's world is able to describe the macroscopic environment. Microscopic means the world in which we live, that we are able to see with our eyes. And yes, like every object around us is an macroscopic object. So yeah, macroscopic object is an object obviously relatively our size. But there is also microscopic objects such as particles, atoms and stuff. So these microscopic objects are some of the times described also by classical physics, but we can find that in some way some of these microscopic objects cannot be governed by classical physics law. So that's why we had to create quantum physics. Basically, what have shown that was the double slit experience, in which we use a photonical cannon. Well, basically, what was done is that you have a source of light going through a double slit barrier, and on the other side, you could see where the photons came through. And what happened was that when you have an object to detect the photons as they go through the double slit, then the light was acting like a particle. But whenever there wasn't something observing, the light was conducting as a wave. And that's really strange, and it creates what we call the duality of light, which is that sometimes it acts as a particle and other time as a wave. And yeah, that's what created basically the quantum physics. At this time, there was Schrödinger's, whom you might know, who trying to explain that with his cats, his famous cats, the Schrödinger cats, which states that if you have a cat in a box, then it could either be dead or alive. You absolutely wouldn't know. But when you open the box, either it is dead or either it is alive. But as long as you don't open the box, we can say that the cat is half dead, half alive. That's what happens with light, for instance, because as long as you don't use a proper experiment to seize the state of the light, it is always being also a particle and also a wave. And that's great, and that opens up a lot of freedom in this field and way to uncover it. So yeah, it's quite strange to see the world on another point of view. But as Feynman said about that, he said, quantum mechanics deals with nature as it is. Absurd. And yeah, I think that's a great quote from him. So basically, I hope that you understood a bit what's the topic of quantum mechanics, and I'll see you tomorrow. Until then, so long, everybody.